Hey everyone. Sorry I am not here today, but I have a meeting out of town, but we'll get going with this. So as you saw on the agenda, everything should start on page 4 of your notes. At the bottom of the page, we're going to be looking today under the section for graphing motion. So yesterday, you should have got started with making your position versus time graphs for the 4 different charts that were on page 8. And you should have ended up with something that's like what's on the bottom of the screen here. Time is on the x-axis, distance is on the y. What we're looking at today is called the slope. And the slope is a measure of how steep the line is. Now, sometimes on our position versus time graph, the slope is the same all the way through. And there was a couple of those on page 8 and page 9 that you might have already seen, but some of them are not. Now, the slope is important in any of our graphs because it tells us something. And so going back to our math definition, slope is rise over run. The change of whatever's on the x-axis over whatever the change is on the x-axis. Now, in a position versus time graph, that is very specific. That is telling something that we have already started calculating in the past. So on a distance versus time graph, that means if the rise over run, the delta y over the delta x, that's the same thing as distance divided by time. So the change in distance on the y-axis divided by the change of time on the x-axis, that is a speed. Now, if we know a direction as well, we're not only getting a speed from a position versus time graph, we're going to get a velocity from that as well. So that's all the notes that we have. Let's go on to the next page, and it's got 4 different graphs for you to look at. So you can pause the video here, and what I'd like you to do is on page 5, take 5 or 6 minutes, talk to the person next to you, and describe what's going on in those pictures looking at the slopes. And some of them the slope's going to change. So pause this video, get that done, and then hit play when you're all ready to go. All right, so let's look at this first graph. It is a distance versus time. We can see that the distance is on the y-axis, time is on the x. And if I have to describe the motion that's going on in this graph, well, this one's pretty clear cut. The object's moving at a constant speed, and it's away from our reference point, or whatever our 0 is, because we have that data at where it's at time 0. So after 1 second, it's 2 meters away. Then it's 4 meters away, 6 meters away. So every second, it's going at a constant speed away from us. Now this is probably different for our second graph. And in our second graph, the object is at a constant speed. The line is flat and diagonal, but now it's coming towards us. So this could be a car that's driving away in the first graph on the top left. This second one could be a car coming back at us, because every second it gets 2 meters closest to us until it gets to where we are at our reference point. Now on this one, this is the first one we have where there's a curve. So what this means is the object is speeding up, because now we're not covering the same distance every second. We're covering a little bit of distance in the first second, a little bit more in the second, but in between 2 and 3, 3 and 4, 4 and 5, 5 and 6, the distance we cover keeps increasing, so this object is speeding up. And you can probably guess what this last one is. This one is kind of the opposite of what we had before. We've got an object that is slowing down. It's going fast to begin with. In that first second, it covers 40 meters, but then it only covers 20, and then 10, and then 5, and so on and so forth. So we see this slowing down. All right, so boys and girls, here's what I want you to do today. Using what we've seen in these notes, looking at these position versus time graphs, and looking at those slopes, I would like you to go to page 10 in your packet, and let's pull up what that looks like. On page 10, where you at? There you are. On page 10, we're going to practice with these motion graphs, and it's going to give you different sections of these position versus time graphs, and it's going to be up to you to figure out what's going on in which place. So, work with your talk partner, use the rest of the time in class, just like what's on the agenda, work on page 10 first. Once you get that done, go back and do the same thing for pages 8 and 9. Graph these data tables on the grid and go back and answer the questions. And now we should know how to calculate the speed of that object in Graph 1 and Graph 2. If you got any questions, put them on Google Classroom for Physical Science. The class code is up by the date. I will try to answer, as I will have some technology with me tomorrow, well, today for you all. But hope you all have a great day, and we'll see you Thursday. Remember, going down to the football field on Friday. Wear comfy clothes. Bye.